Hey guys, in this video we are going to talk about how to factor perfect squared trinomials as well as difference of two perfect squares. So those are the two special types that you will see whenever you are factoring polynomials. So up at the top of page 25 in your notebook, you see the same flow chart that we talked about previously when we started talking about how to factor trinomials when a is equal to 1. Off to the side here, you should see special products. So you're looking for perfect squares in both 2 terms and 3 terms. We're going to start by talking about the 2-term ones. So first, let's start off by remembering the special binomial multiplication that we talked about last chapter. So if you recall, to multiply these, you're simply distributing each term from the first set of parentheses to each term in the second set of parentheses. So x times x is x squared. X times negative 5 is negative 5x. 5 times x is 5x. And 5 times negative 5 is negative 25. So you should notice that these cancel out because they equal to 0. So you should get x squared minus 25 as the multiplication of those two binomials. Let's do the same thing here for number 4. Distribute the x first, then distribute the y. X times x is x squared. X times negative y is negative xy. Y times x is positive xy or positive yx. Remember that multiplication goes in either direction, so it doesn't really matter how you write that. They're both like terms. And then lastly, y times negative y is negative y squared. Once again, the middle two terms cancel out because they are the same. And then x squared minus y squared is your product. And I want to amend what I said here. They're not the same. They are equal to 0 when you add them together. That's why they cancel out. All right, so if you notice in either case, or in any of these cases actually, the middle terms drop out and you're just left with perfect squares on both ends with subtraction in the middle. And that's exactly what difference of two perfect squares is. So if you look in this box here, it says there are two terms of perfect squares with a subtraction sign between them. So first you want to find the square of both terms, write the factors as the sum and difference. All right, so if I'm looking at the first one here, difference of two perfect squares is pretty simple. It's always two sets of parentheses, one of them with a positive in the middle, one of them with a subtraction, because that's going to make your middle term drop out, which is what we want. Then take the square root of x squared, which is just x. That goes in the front of each set of parentheses, and the square root of 25 is 5. That goes in the second spot in each parentheses. And that's it. That would be your answer. Number 6. Same idea, even though the x squared comes second. Start by writing your parentheses. One with a positive, one with a negative. The square root of 25 is 5. And the square root of x squared is just x. So as you can see here, I'm putting the square root of each term in the same spot as the term was in to begin with. So the square root of 25 came first, so its square root goes in the first spot in each parentheses. X came second, so the square root of x squared goes in the second spot in each parentheses. And it's always like that. You never have to worry about where they go. All right, number 7 should look familiar to you. We just multiplied to get that here in number 4. So it's the exact same thing. Two sets of parentheses, one with a positive, one with a minus. The square root of x squared is x, and the square root of y squared is y. Oops, I'm really good at drawing boxes today. All right, turn the page. Number 8. Same idea here, but there are bigger numbers in front, so don't be afraid. Two sets of parentheses, one with a plus, one with a minus. And I'm going to back up because I've already messed up. You got to take a look at this. What sign is in the middle here, ladies and gents? That is a plus sign. Now remember, I said that difference of two perfect squares had to have subtraction in the middle. If there is not subtraction in the middle, it is not difference of two perfect squares because difference means subtraction. So difference of two perfect squares means subtraction of two perfect squares. So you can't actually do anything with this, so we call it prime. Prime just means that it cannot be factored further. All right, number 9, subtraction in the middle this time, so let's go ahead and make those parentheses. One with a plus, one with a minus. The square root of 49a squared is 7a. The square root of 49 is 7. The square root of a squared is a. That goes in both spots. All right, the square root of 100b squared is 10b. The square root of 100 is 10. The square root of b squared is b. And that's it. One more, 2 sets of parentheses, one with a plus, one with a minus. The square root of 5 is not a perfect square, so we don't have to worry about that. So we're going to take the square root of x to the 4th, which is x squared. The 5 stays the same. And the square root of a negative 5x squared is going to be, actually, let me back up. The first thing I told you guys to do every time you're doing one of these is to check for a GCF. And clearly, I didn't do my job. So let's go back. Notice that they both have 5s. Let's go ahead and divide that out. They both have 5s. That's part of the GCF. And they both also have x squareds. Also part of the GCF. So 5x squared goes in front. And when you take that out, you get x squared minus 1, because negative 5 divided by 5 is negative 1, and the x squareds cancel. Now, looking at what's in the parentheses here, you should notice that this is still 2 perfect squares separated by subtraction. So that's still difference of 2 perfect squares. So I'm going to put the 5x squared, which was my GCF from before, back out in front, and I'm going to do this difference of 2 perfect squares. The square root of x squared is just x, and the square root of 1 is just 1. So this is my final answer right here, this bottom section. So sometimes you got to take the GCF out first, and then you will find that there are difference of 2 perfect squares after that. All right, that's it for difference of 2 perfect squares. Let's move on to perfect square trinomial. And just like before, we are going to start by remembering what a binomial squared looks like, which would be this right here. Now remember, squaring something is the same as multiplying it by itself. So this is the same as x plus 5 times x plus 5. And then we would multiply like this. We get x times x, which is x squared. 5 times x is 5x. It was x times 5, but 5 times x here is also 5x, and 5 times 5 is 25. The two terms don't cancel out this time because they're the same sign. So that becomes x squared plus 10x plus 25. All right, and we would do the same thing with number 15. This is the same as 2x plus 6 times 2x plus 6. Distribute the 2x. So you get 4x squared. 2x times 6 is going to be 12x. 6 times 2x is also 12x, and 6 times 6 is 36. When you combine the middle two terms, you get 4x squared plus 24x plus 36. And that's how you do every single one of these 4 problems. We've done that before. So now down at the bottom of page 26, it says, look at your answer. What do you notice about the first term in the answer when compared to the first term in the binomial? All right, so in the binomial, which was 2x plus 6 in this case, you should notice that 2x squared is 4x squared. So it is the answer is the first term in the binomial squared. Okay, now what do you notice about the last term? Well, same thing. The answer is the second term in the binomial squared. All right, now number 3 says, look at the middle term of each answers. Can you create a pattern using the binomial squared? Well, in this one, you should see 2 times 6 gives you 12, right? And 12 times 2, because there would have been 2 of them from the multiplication, 1 from 2x times 6 and 1 from 6 times 2x. If you multiply these 2 together and then multiply by 2, you get the middle. And that's true for every single one of these. So the middle term of each answer does create a pattern. It is the middle term is 2 times the product, which just means multiplication, of both terms in the binomial. And this is always true. So when we get into factoring perfect square trinomials, if you can remember that little formula, it can make your life a little bit easier and make some of these problems a little bit quicker. Now, the good news is, if you don't remember the formula or it's too tricky to try and go through and do all that work, it's okay. You can still factor these without knowing the formula, but we're going to practice using the formula. So when you're looking at some trinomials, the first thing you want to look at are the first and last terms. If they are both perfect squares, you want to then take the square root of each, multiply them by each other, and then multiply by 2. If you get the middle term from that, that means that these are perfect square trinomials, and you can just skip straight to the answer. All right, so even though it's not there, there's an invisible 1. The square root of 1x squared is a perfect square, and 16 is also a perfect square. So the square root of 1x squared is just going to be 1x, and the square root of 16 is 4. 4 times 1 is 4, times 2 is in fact 8. So we can skip straight to the answer. And what I mean by that is, I know that this is a perfect square trinomial, so I'm going to have a binomial squared. The sign of the binomial is the same as the b term, so in this case it's a plus. Then you just want to take the square root of the first and the last terms. So the square root of 1x squared is just 1x, and the square root of 16 is 4. And that would be it. That would be your answer. All right, take a look at 19. The square root of 4x squared is 2x, technically, and the square root of 1 is 1. 2 times 1 is 2, times 2 is 4. So once again, we have a perfect square trinomial, so it's going to be a binomial squared. The b term is positive, so put a plus sign. The square root of 4x squared is 2x, and the square root of 1 is 1. Number 20. Same idea. Invisible 1. The square root of that is 1x. The square root of 81 is 9. 1 times 9 is 9. Times 2 is, in fact, 18. All right. Perfect square, or squared binomial here. This time, the b term is negative, so you're going to have minus in the middle. The square root of 1x squared is just 1x, and the square root of 81 is 9. All right, let's do one more together. The square root of 36x squared is 6x. The square root of 1 is 1. 6 times 1 is 6. Times 2 is negative 12. So we have a binomial squared, minus sign in the middle this time, and then the square root of 36x squared is just 6x, and the square root of 1 is 1. And that's it. Those are your special types when factoring these types of problems. In the next video, we're going to talk about factoring by grouping, which is very similar to factoring using GCFs.